No one knows how many black holes there are in the universe. Black holes do not emit any light of their own, making them impossible to see directly with telescopes. The only way we can detect black holes is by looking at the effects they have on things we can see. When a black hole resides near another star, we can see the elongated shape of the star as material is pulled away by its incredible gravitational pull. We can also see the high energy radiation that accelerates away from the spin axis of the black hole generated by infalling material. This is X ray and gamma radiation that, if directed towards Earth, are among the brightest objects in the universe. A new technique that's only recently been possible with our latest telescopes is that of gravitational lensing. We can see background stars flash brighter as their light is magnified by the gravity of a black hole, creating a lens that bends the light traveling towards us, making a momentary flash of light that we can detect. We've theorized about black holes for centuries, and they were a prediction of Einstein's theories of relativity. But it was only recently that we've managed to directly image the region around a black hole. In 2019, the Event Horizon Telescope collaboration took this image of the black hole at the center of the galaxy called M87. Called M87 star, this is a direct image of the area around a supermassive black hole some 6.5 billion solar masses. What's shown here is the clear delineation that marks the event horizon, a boundary that once crossed allows no light, or nothing else for that matter, to escape. A second image was released in 2021 of the black hole at the center of our galaxy, called Sagittarius A star, a 4 million solar mass black hole devouring material and emitting radiation. The images from the Event Horizon team are the first direct images and proof that black holes actually exist. So, from all of our theories and observations, the conclusions are that there is probably a supermassive black hole with masses millions of times that of our Sun embedded in the centers of every galaxy in the universe. We see them as quasars from all corners of creation. But what about the smaller ones? What about the black holes the sizes of stars, so-called stellar mass black holes? These are created when stars like Betelgeuse die. They explode in supernovae, creating an astounding nebula and leaving behind either a neutron star or a black hole. How many of them are there? Since we can only see a black hole by observing its effects on its surroundings, we can't know this for sure. Some black holes are lurking in the space between the stars, silently floating in interstellar space. We would never know they are there until they get close to something we can see. With that prospect in mind, it's a reasonable question to ask, what's the closest known black hole to us? The answer is surprisingly elusive. Astronomers from the Event Horizon Telescope collaboration tell us that the closest known black hole is V616 Monocerotis, an 11 solar mass black hole some 3,000 light years away. It orbits a 1/2 solar mass K-type star every 8 hours. The next one farther out at double the distance, 6,000 light years, is the 15 solar mass black hole Cygnus X1. But there is another tantalizing possibility. A black hole much, much closer than V616 Monocerotis and Cygnus X1. There is evidence of a 10 solar mass black hole surrounding the double star system V Puppis. This system consists of two B-class stars orbiting extremely close to each other, some 1165 light years away. These stars are so close together that they orbit each other once every 1.5 days, and as they do so, they block each other with respect to Earth's line of sight. These sorts of binary systems are called eclipsing binaries. As they orbit each other, blocking out the light from their companion, our telescopes on Earth measure a light curve that shows a dipping and brightening as each star eclipses the other. But astronomers notice something else. The period of the light curve was not what would be expected if these two stars were alone. Something else was noticed, creating a strange periodicity in the light curve that indicated there was something else out there. Something with a gravitational pull equal to 10 solar masses. Upon searching, nothing in any visible, infrared, ultraviolet, X-ray, gamma ray, or radio wavelengths were seen. Whatever was there was invisible. Whatever was there was also too massive to be a planet or several planets. Astronomers suggest that a 10 solar mass black hole is circling both stars about 10 astronomical units away, tugging on them, creating the strange period of their light curves. If this is true, then V Puppis is home to the closest known black hole. And because these stars are bright, about as bright as the star Vega in our night sky, V star V Puppis is also the first naked eye black hole. The constellation Puppis is visible just below Canis Major in the winter sky in the northern hemisphere. Looking for bright blips in the sky is probably our best bet for finding more silent and dark black holes in our galaxy. This technique, called gravitational microlensing, is utilized in many sky surveys like the Dark Energy Survey and the upcoming Large Synoptic Sky Survey using the Vera Rubin telescope. Seeing light in 2023, this telescope will look at the entire sky several times each week, allowing astronomers to scour the resulting data and look for hundreds, perhaps thousands, of tiny blips of light betraying the location of these celestial ninjas.